I bought this Pokemon Emerald Game Boy Advance game for only $30 from a viewer named Jason, but that's because it's amazingly broken. Let's take a look. This Pokemon Emerald game might sell for up to $230 on eBay, so it's definitely worth fixing, but it's very broken. The viewer that I bought it from someone on Mercari for $100, but he didn't know it was broken. So unfortunately, he got ripped off because he didn't know it looked like this inside. Oh boy. This one is quite the mess. This battery is barely holding on here. A bunch of the soldering on this chip is no good, and it looks like maybe even one of the legs have been torn off. This chip needs to be resoldered. This, I think that component's still there. It's kind of hard to tell. This needs to be resoldered. These guys look like they're barely there. I'm not sure about that. Let's look at the other side of this game cartridge. Okay, and we've got somebody tried to install a trace here, but it's not connected to anything, so that's not going to work very well. Got some solder here. Wow. It looks like, yeah, this was liquid damaged at one point. Okay, I think we need to get under a microscope and have a better look at this so we know what we're dealing with. So this looks like some of the worst part. This whole part of the board has just been torn off, and then they tried to run a wire from the battery over to these points here. This point, though, is not even soldered on, so I'm not sure the point of that. This looks pretty bad. We got one leg, two legs that are torn off, and actually it looks like this leg could be torn off as well. That could be bad, but I think maybe we'll be able to fix that. I'll have to take a look at that in a minute here. This soldering is just horrible. Same over here, really bad. This is very dry soldering, you can tell because of these peaks right here, this pointiness. And what do we have over here? More just really bad soldering. This component's like almost destroyed. I think they might have been soldering without using any flux at all. And even before they did all this work, it looks like this board has been liquid damaged. And this is the best soldering on this entire board. I think the first thing we need to do is remove this battery, take some of these chips off, and have a better look at the board. And then we can assess from there. Now I've got a soldering iron started up. We've got our air filtration turned on. Now we're ready to put on some flux. Flux will just help this solder flow nicely. And then we'll come through and start removing these chips. Like I said, we're just going to do the main chips. I don't think we need to do all of them at this point. But we'll see. We might need to by the end of this video. I'm first going to start just by desoldering this wire right here. I want to get this battery up first. There we go. Good enough. It's a big old blob of solder right here. Okay, there we go. Now we can see, oh man, that just looks so bad. I'm going to use my hot air soldering station to remove this chip, and then we'll get a look at the board. Also, I'm going to get some of this solder off. There's a ton right there. To do that, I'm just going to use a little bit of solder wick. And that will just wick up some of this excess solder. You can see it working its way up the braid. That's the point of solder wick. After all of that we took off, and there's still some here. Okay, that's better. Now I'm going to get my hot air soldering station started up and up to temperature. I'm going to add some flux onto this chip. And then we will remove the chip and see the condition of the chip and the condition of the board underneath. I don't have high hopes. It looks pretty bad so far. And very surprisingly, the pads on the board itself actually don't look that bad. I think these are actually all probably usable. Now the chip itself though, we're going to have some issues with. So clearly we have one issue right there. That's a broken pin. These are all bridged, that's fine, we can fix that. The other issue is on this side. We've got two more broken pins. There's not much there to work with, but I think I might be able to tack a wire onto these. If I can't do that, I should be able to sand this down a little bit and get a little more exposed on these pins. And once these pins are exposed a little more, then I could for sure solder onto that. But I might be able to do it just on this. So then the next steps, we need to clean this board up a little bit better so we can see what exactly is going on with all this liquid damage and if that's something we need to repair first before we worry about all these other things. I think I will remove this other chip as well right here, just so we can have a look under that. And I'll probably also remove this chip too, so we can look under that, just so we have a better idea what's going on this board. So let's remove those, and then we'll inspect it more and create a plan. So we've done a little bit of cleaning on the board, but we need to do some more cleaning on these holes here and get any of this corrosion out, and then do some testing and make sure that these circuit traces are good in here. Looks like most of the issues with liquid is down here, or corrosion. As we move up the board there, it looks like there's less of it. Not really any of it actually, so that's good. I do want to scrape some of this off where I can see there's been corrosion underneath, just to make sure that, you know, all the corrosion has been removed and there's no damage on the copper. Then we can come through with some conformal coating and coat that again to make sure the copper doesn't start corroding. Up here, it actually looks pretty good up here. There's a little bit here, but that's not really super important. Now on the back side, we've got quite a bit of corrosion too. So let's have a look at that, although I do want to see this. I'm not sure, that's very black. We might need to, that looks like kind of like solder that is kind of corroded over time. So we might need to work on that a little more. Now this back side though, I'm a little worried about this. Got quite a bit of corrosion in these holes. And then all of this kind of discolored stuff is from the solder mask separating from the copper. All mostly looks okay as far as the integrity of the circuits, but we need to inspect all of this kind of stuff to make sure there's not a break in these circuit traces here. That one looks good. Yeah, these all look okay. That one we'll need to take a closer look at. Maybe that one as well. This one for sure. Although this doesn't look like there's anything connected to it, so that's probably not an issue at all. Okay, now these definitely could be an issue. So we need to scrape this solder mask off. And then we will do some resistance testing to make sure that those circuits are all intact. That's just scraping right off. Now so far, these circuits actually all look fine. I'm kind of expecting that one of these there's going to be a break in the circuit, but so far they look fine, so that's good. If that's the case, then all I'll need to do is come through and put some conformal coating back on this, and we'll be good to go. Okay, we'll get some I don't know what I was saying. We'll get some IPA, rub that off and clean it. Those actually look okay so far. I've been trying to decide if I just need to solder these components onto a new board, but so far these are looking okay, so that's good news. Okay, and then we got some more over here. I have made some videos in the past where I do some of this work, and some of these vias are where the main problems are. These ones so far look okay. The copper is definitely, you know, corroding, but once we clean it up, it actually mostly looks okay. Some of the other videos I've done, kind of like right here, kind of this like, almost like a collar there, that's where a lot of the issues were. But so far, these look okay. So far, this is one of the rare instances where I start inspecting it and it looks maybe not quite as bad as I thought it would be. That doesn't happen often. I always feel bad when I get this stuff from people who were ripped off, like on eBay or Mercari or wherever, Facebook Marketplace, because it's so easy for sellers to just say, oh yeah, it works fine, practically brand new, and then to just ship it out. Now a lot of places, I'm not clear on why the seller didn't go to Mercari and get his money back, but there's some reason that didn't work, and so he had it and wanted to send it in to me to see what I could do. So if you guys ever have good stories like that, just contact me on my website, TronicsFix.com. I'm always looking for a good story. So anytime, you know, if you've been ripped off, or, you know, a repair shop tried to fix it but couldn't, or, you know, Sony tried to fix it but couldn't, anything like that usually ends up being an interesting story. So if you have stuff like that, especially on interesting electronics, then contact me on my website, and maybe we can work something out so I can make a video about it. I normally don't do repair services because of instances just like this one. Like, I'm not sure that this is even going to be fixable, and so I usually just try and buy stuff from people, but I have made exceptions in the past depending on the item and what all is wrong. But if I'm not sure I'm going to be able to fix it, it's pretty hard for me to, you know, have somebody send it in so I can try to repair it, because I don't know that I can fix it, so it's hard for me to want to offer a service where I fix stuff when I'm not sure that I can. So, okay, we're getting close here. There's a lot of corrosion on this, but I'm hopeful that this board is savable. Okay, let's clean that up, see where we are after a little bit of cleaning. Now we have this board pretty clean, and we've gotten a bunch of the corrosion scraped off. So what I'm going to do now is test each of these pins right here and make sure that there is continuity from the pin to the corresponding pin or pad or circuit trace over here. That'll just make sure that those connections and circuit traces are all good. So right here, we're going to go from here over to here. Oh, this is going to be easier if we just make it beep. Beeps, okay, good. This one we don't have a corresponding pad anywhere on the board, at least on this side. So here we're gonna go up right there. Good. Here we're gonna go to here. Good. And I'll check that area. So what I'm doing here is checking to make sure that there is continuity from here over to here, and there is. This little spot right here that looks a little bit dark, if there was a break right there, then my meter would not beep. Good there. Good there. Good there. Good there. Yep, so these are all doing good. Okay, so I'm going to go through and check the rest of these off camera. If I find one that has a problem, then we'll film how to fix it. Okay, and we've got it pretty clean and most of the corrosion removed. So I think we're good to start rebuilding this board. So one of the things we need to do is fix stuff like this. All this solder is just all over this capacitor. I'm going to need to go through and check each of these pads and reapply solder onto each of these pads. I'm going to need to reinstall this capacitor. There's a capacitor that was attached to here and then over to here, but this copper pad has just been totally worn away. So I'm going to install the capacitor on this side and then see if it can reach over here, and if not, I'll install a jumper over here. We need to redo all of this soldering. This actually doesn't look too bad. And then after that, we can install this chip and then deal with the broken legs on that chip. That's probably going to be one of the most difficult parts of this. So we'll save that part till last. Let's get to redoing some of these components and some of this solder. So the problem with this guy is that on the very end of it, there should be metal on the end, and that metal's just been torn off. So all we're left with is kind of the internal part of the resistor. And unfortunately, there's just not enough there for me to solder to. So I'm going to see if I can get a good enough connection to see what this is rated at. 0.8 ohms. Okay. It's really hard because there's just a tiny bit of metal on this side of it. Right there, at least I think, and that's all I can get. So I think it's a 0.8 ohm resistor. I'm going to look around and see if I have one that's maybe a little bit longer even, and then we'll replace that. We'll replace this resistor with that resistor. You can see this bottom part is the part of the copper that tore off the board right there. All right, let's see what I can find, and then we'll get this replaced. Okay, and I did not find an exact resistor that matches that, but I did find a fuse on a PlayStation 5. So it is significantly smaller, but hopefully it'll work anyway. It's rated the same. So there we go. And I mean, I would assume that a fuse and a resistor kind of have some different characteristics that may be important, but I also think it'll work just fine. So we'll find out. Okay, now that is installed. That's actually really solid. So now what I'm going to do is go through and fix these joints, all of these joints, and all of these joints. I'm going to use plenty of flux. I need to make sure these joints are nice and clean. There looks like some oxidation we need to try and get off of there, so hopefully that'll be enough to do that. went ahead and knocked a resistor off while I was going there, so let's try and get it put back on the board. There we go. Oh, almost. Not quite. Sometimes with the larger iron, it's hard to get the tip right where you need it. To get the heat on there you need. Let's try the small one. This one, we can get right in there, right where we want it. Okay, good. Good. There we go, that's not going anywhere. So I'm working on rubbing some of this oxidation off on this pad right here with my iron. There's probably a better way to do it, but this is also working. Add some more flux here. That'll help this solder flow onto all these pads real nicely. There we go. Yep, those are much better. Now the other side. We need to do basically exactly the same thing. Okay, and now we have all that done. It's time to reinstall the chips. And now with these chips soldered on, I'm just going to come through and check each of these joints. Make sure they just have a really nice connection there. And get some fresh solder on my small iron. Now let's take a look at the big chip, figure out what we need to do there to get this thing soldered on all the way, including those broken pins. I'm going to go through and do the same thing here, make sure that each of these pins is soldered on nice and solid, and then we'll take a look at those broken pins. Okay, there's one. We've still got two, we still got one on this side and one on this side. So we've got those two. This one right here and this one right here. Now this one is probably going to be the hardest one. There's just a little nub sticking out there. So we got to see if we can get anything soldered to that or not. Let's get some more flux over here. There we go. Let's get all the coating off of this wire. This is like a coated wire. So I got to get the coating off so all the solder will stick. So we're going to go down here like this. Okay. That's kind of what we need, but then we need to make sure that the top part is actually soldered to the pin up here. Is that? Okay. And we got it. Well, that was easy. I'm just gonna cut this off. Cut off the excess wire. There we go. Okay. So I think we have that chip soldered on. Now we need to get the battery soldered on. So we are gonna need to put it about right there. And let's solder on the other side first. I'm gonna switch to my large iron here since this is such a big battery. And we're gonna move it over here as far as we can. There we go. And that's not quite lined up with the pad. We want a little better alignment there. Still not. Getting closer. Closer still. Right about there is pretty good. Okay, that's pretty good. Now this side, I think we can actually scrape off some of that solder mask right down here. There we go. Now I'm going to push down here. Again with my large iron on this one. I'm going to push down. Hopefully get it to connect down here. Not quite connecting because I can't get it to go quite down all the way. Oh, did we get it? We're really close. Not quite. It's going to be better to connect a wire here anyway because I don't want that to pull up on that trace. So I think what I'll do next is connect a wire from one side to the other. I've already got a little wire on my tweezer here. So I'm just going to bring that wire down here. Why is that so wiggly? It is just how it is, it looks like. It's a little bent probably. Okay. Okay, and I think we're ready to test it. As I was looking at this more and testing these pins more, this one has broken off, and then as I was pushing on it like this, pushing on this one, it just totally broke off too. So yeah, here it is right here. That's the piece of the pin that broke off. So then I removed the battery And I also looked at these pins, and this one broke off as well right here. So we've got 1, 2, 3 more to fix. I'm probably not gonna film that part. You guys already see how to do that. So I'm just gonna cut to having this done so we can test it. So I just finished with the game. That one resistor that I replaced, it actually was supposed to be a capacitor, so I did fix that problem. Now let's start it up and see if this game works. Oh, we got a Nintendo logo, that's good news. Come on! Yeah! Everything looks great. That was a difficult fix. Also, I do want to show I am using the same game, so I didn't just, put a working game in there. I didn't actually put the battery in yet. I'll mount that in next. I just wanted to test it and make sure it worked. If you like this type of video and you want to see one where I tried to fix 9 broken Pokemon Game Boy games, I'll put a link for that video up on your screen now so you can come hang out with me over there and see if I could fix those. Thanks again for watching today, and I hope you have a good one.